Good morning or good afternoon, wherever you are. Welcome to the first session of the course of The Intelligent Optimist on the healing powers of hydrogen with Tyler LeBaron. And I'm very happy that we're able to do this because I'm sure that you're going to learn very interesting things over the next 3 weeks and when we have our sessions. Welcome, Tyler. Good to have you with us today. And I want to, before we get going, I want to make sure that we agree on how we're going to work together here on today. I'm sure this will lead to all kinds of questions. Tyler's presentation will invoke those in you, and that's totally fine. We want to have an interactive conversation with you. So whenever you do have questions, please email these to courses@theoptimist.com, that email address, courses@theoptimist.com. We used to have within the Google Hangout system a chat function, but for some reasons Google has changed the infrastructure of the Hangouts, and for the moment that function is not available, so we have to do it through email, which should work perfectly fine. Sherry Pula, who's behind the scenes coordinating everything, she will receive those, and thank you for doing that, Sherry, and she will receive those emails. I'll make sure I'll see them, and then we'll get them to Tyler as well. So that's your way for your questions, courses@theoptimist.com. You're free to send those questions already while Tyler is presenting, and I may interrupt him if it's on topic, and otherwise, obviously, we'll get to your questions at the end of the presentation. So that is for how we're going to do this. And obviously, this is all recorded, and as soon as the broadcast is over, there will be a YouTube link, which we will share with you, but ultimately it's the same link as you've used now, and then you can always watch the recording as well if some things were not clear or you want to re-listen one more time. So that's all available for later on, and obviously we do this in the next 2 weeks as well when we go deeper into this topic. So again, welcome to Tyler. Tyler, you set up the Molecular Hydrogen Foundation, MHF, Molecular Hydrogen Institute, you also call it, and you were in fact doing something that made a lot of sense. The whole story of hydrogen is a story that is much more developed in Asia, in countries like Japan and Korea, South Korea, where many people have been benefiting from these healing powers that hydrogen provides for decades already, and it was relatively unknown here in the West. And the good thing that the Molecular Hydrogen Foundation now does is bringing in one environment all that research that has been done mostly by those scientists in Asia over the past decades, showing what hydrogen can do for our health. And that's a major contribution to an interesting and important topic, because we have found out, as you will explain in far more detail, of course, that hydrogen is has powers, has antioxidant qualities, and that are going much further than what we usually take as our supplements. And it's kind of easy to take, and for all of us. So there seems to be some kind of miraculous thing here with hydrogen that's available to all of us in a very simple way. But you will know and learn much more about that in the next 3 weeks. So Tyler, it's up to you. Once again, welcome here, and please take it from here and let me know at any moment when I can be of assistance or help you, and I will interrupt you when I think the audience needs further clarification. So on towards the healing power of hydrogen.
Okay, great. Thank you. Thank you for the introduction. Thanks for allowing this opportunity to come and educate and talk a little bit about hydrogen and the history of hydrogen and alkaline water and where everything is at. It's very, very fascinating, actually. And so I don't plan to bore everybody completely with technical, scientific terms and things this whole time. A lot of that is there on our website, molecularhydrogenfoundation.org, and so you can read about that. What I want to explain is some of the history and some personal stories and some historical stories about the development of alkaline water and of hydrogen water, and then yes, explain some of the science so you can follow the stories better and that you have a better understanding of what is real and what is not real. And ultimately, through these courses, you'll be able to gain enough knowledge that you can actually take a test from MHF and become MHF certified, and you'll have that core knowledge with you. But Molecular Hydrogen Foundation, it is a science-based nonprofit. And so we don't sell hydrogen products, we don't represent hydrogen companies or things, but we are focused on advancing the education, the research, and the awareness of hydrogen as a therapeutic medical gas. And that's really what it comes down to be, is hydrogen as a medical gas. It's an emerging area in biomedical research and biomedical sciences, and it's extremely fascinating, and it's taken off at exponential growth. And the bottom line is, hydrogen has been shown to have therapeutic potential in about 170 different human and animal disease models, and essentially every organ of the human body. So this is no small joke. This is no small little finding. This is quite large. It's an interesting parallel or dichotomy, if you will, that such a small, indeed the smallest molecule, can have a very large, perhaps the largest, potential impact on human health. And so before we do all these things, let's talk about a few stories, and so we can kind of get a basis for everything that's going on and has happened. So first on my end, I always get the question, well, you're only like what, like 19, 20 years old? How do you even know anything about hydrogen, or how did you get into this? And the answer is, I stumbled upon this, quite when I was young. In fact, in 2009, I came across the concept of alkaline ionized water, or electrolyzed reduced water. And since 2009, I have really started studying all of this area of water, and quickly came across hydrogen, and that's why I'm doing all these things I do now. So I'm going to explain some of that. So in 2009, I came across the alkaline ionized water, and I heard a lot of fantastic and unbelievable stories. But there was something that I heard so much, and there was something kind of inside of me telling me there's something more to this, that you can't just blow it off, that something needs to be researched. And so as I started to do the research, and I came across in the scientific literature it was referred to as electrolyzed reduced water, I then quickly saw traces of hydrogen. And that's really what took me to the next level. Now there's some more stories inside of there, so you kind of see that I know what it's like to believe in something and not have the answers of how to explain it. Because when I first started trying this alkaline ionized water, and I saw many people's testimonials and different things, and I saw some of the preliminary research, I didn't quite understand it very well myself. I was just starting my undergraduate studies at the time as well. And I remember I really wanted to understand some of these claims that people were talking about, such as the benefits of the alkaline pH, and the idea that cancer can't survive in an alkaline environment, and Dr. Otto Warburg's, what it's claimed that he has said, but we'll talk about that more, which actually he didn't say that. And things about microclustering, and specifically, what is this ORP, this oxidation reduction potential that everybody talks about, this antioxidant, these free electrons of something in the water. So when I was at the university, those were my first questions I started asking my chemistry and biology professors is, hey, what is this ORP? And they're like, well, what do you mean? What are you talking about? And I tried to explain, and the more I tried to explain this ORP or microclustering or anything else, the more I felt belittled, the more I felt kind of ridiculed, if you will, for why would I even be involved with any of this, these areas that have no science to it at all. But again, I knew deep down there was something to it, and so I was guided in the direction to continue studying that, and that's when I came across hydrogen. And I came across an article published in a very prestigious and well-recognized journal called Nature Medicine. And this article simply showed that inhalation of hydrogen gas, or even hydrogen dissolved in media, in like cell culture media and solution, could have very therapeutic effects. That it could have antioxidant effects, that it helped prevent the damage of ischemia reperfusion injury, which, like low oxygen levels and the blood going back into the brain. It could help prevent a lot of that damage in the rat model. And that was very intriguing to me, but even more so because at the time I still didn't understand a lot of the science. Some of the biochemistry and physiology professors were like, this this is interesting. There really might be something to this. And so that's really when I wanted to really study all the benefits of hydrogen. Now, there's a couple things that we need to clarify then in terms of terminology. When we are talking about hydrogen, we're talking about simply hydrogen gas, and that's H2. And there are 4 or maybe even 5, one could say, different forms of hydrogen. And so we're all on the same page. I'm going to educate a little bit on this. In fact, I'd like to show a PowerPoint, just a PowerPoint picture to talk about this. Let me pull this up. And the goal of this would simply be to help you follow what are the different forms of hydrogen, so you don't get too confused. Okay. So I think you should be able to see my screen now. And I have put 4 different types of hydrogen here. There's one on the top that's called a proton, and it's a positive charge. It's just a proton. We know protons are positive. And you'll notice in the center it just says H, and that's just, it just has a proton in the center. And then on the outside, it shows that it's missing an electron. So there's no electron there. It's just a proton. This H plus, or this proton, this is called H plus ion, or positively charged hydrogen ion. This has reference to pH. This is what pH means. pH is a measure of the concentration of these H plus ions. And in water, you always have H plus ions. In pure water, you have 1 × 10⁻⁷ moles of H plus ions. And if you take a negative log of that, a mathematical function, you get 7, and that's why it's pH 7. In fact, the P in pH has reference to a logarithmic function. So in reality, pH stands for the negative logarithmic concentration of the hydrogen ion, or the proton. So that's what pH is, and it's all about the proton, this positive hydrogen ion, and that's very different than what we're talking about with molecular hydrogen, hydrogen gas. The other form of hydrogen is this atomic hydrogen, which is a neutral, just as one hydrogen atom and electron. You can see in the diagram there's a proton. This time it does have an electron. Because it has 1 proton and 1 electron, right, a positive and a negative, that makes it neutral, so it's neutral. This is atomic hydrogen. This has been termed in times called the active hydrogen. In some of the electrolyzed reduced water research, they call it active hydrogen, because at the time they did not believe it was possible that hydrogen gas, or molecular hydrogen, could have any biological effects, because it's so mild, it's so basically biologically inert is what it was thought. So they just assumed that maybe it was an atomic hydrogen that was accounting for this, because atomic hydrogen is very reactive. In fact, atomic hydrogen is considered a free radical, because by definition, a free radical is something that is missing an electron, or has it better said, an unpaired electron. So if you'll notice, with atomic hydrogen, there's only 1 electron there, so there's no pair. There's just an unpaired electron. So that's atomic hydrogen. Then we have hydride, or negative hydrogen ion. If you'll notice, that simply has 2 electrons but only 1 proton. So two negatives and 1 positive, you still have a negative charge. So that's what a hydride is. These are extremely reactive, extremely, they're going to react with solution to make a very high alkaline pH. They're just very active. You use them in industrial chemistry synthesis and organic chemistry to synthesize organic compounds, for example, using like sodium borohydride and different things. So this is the hydride. And then we have what we're talking about for the rest of the day is really molecular hydrogen. Molecular because it's a molecule. And a molecule is simply 2 atoms or more that are bound together. So you can have a molecule of water, or you can have a molecule like hydrogen, molecular hydrogen. And so you see there are 2 H's. So there's 2 protons, and each one has their own electron, and they share it. So that's molecular hydrogen. That's hydrogen gas. And it's not, another question people get all the time is, well, hey, isn't water already 2/3 hydrogen? Like water is H2O, right? Well, this is totally different, because this molecular hydrogen, they're only bound to each other. Just take a look at the diagram. I'm going to take it off screen share, but just again, remember what molecular hydrogen looks like. It's just 2 hydrogen atoms that are chemically or covalently bound together and sharing those electrons. And going back to the question, as far as with water, if we look at the structure of water, we can think of Mickey Mouse, for example. You can think of it as the big oxygen and then the two hydrogens that are attached to it. Notice those hydrogens are attached right there directly to the oxygen. They're not attached to each other. So water, yes, it has hydrogen atoms, in the water molecule, but that doesn't make it hydrogen gas. That's why, because hydrogen is explosive, right? But you can't light water on fire. I mean, unless you do something to the water, like electrolysis, make hydrogen gas to change the properties or something. But yeah, you use water to put the fire out. You can't just light the hydrogens on the water molecule. And virtually every organic compound has lots of hydrogen. In fact, sugar or glucose, the chemical compound is C6, 6 carbons, H12, 12 hydrogens, O6, and 6 oxygens. So there's six hydrogens in every molecule of glucose as well, but that doesn't make it water. It doesn't make it hydrogen therapeutic for you. So in order to understand that, we need to understand, we're talking about molecular hydrogen. It's just simply two hydrogen atoms that are bound to each other. And this hydrogen gas makes it's the smallest molecule in the universe because it's just bound only to each other, which makes it so it has some difficulties and some benefits. A difficulty with the hydrogen gas is that it's difficult to contain. You can't simply just put it in a plastic bottle and it's going to be good, have a shelf life for weeks and months and years, because the hydrogen gas, such a small molecule, will just easily, rapidly diffuse out. It's a lot smaller than, say, CO2, a molecule with the carbonated beverages, which is why they can have it in plastic containers. You can't do that with hydrogen gas because the hydrogen molecule is so much smaller, it can just diffuse and permeate right out of the plastic containers. And people have noticed this also, those who have been in this area of, say, alkaline ionized water, and they have it can have hydrogen gas in it. They have noticed that it only lasts for so long before the properties go away, before the negative ORP is gone, before the therapeutic benefits are gone. And the reason why is because the hydrogen gas leaves. The hydrogen gas is such a small molecule, it just dissipates right out of the plastic container and leaves. And if the hydrogen gas is gone, then not only is the therapeutic benefit, well, not only is the negative ORP gone and it's back to positive, because the hydrogen gas is what's responsible for the negative ORP, but also the therapeutic benefits are also gone. And that's why people have noticed they can't leave the water out for an extended period of time, because it loses those beneficial properties, and it's because of this hydrogen gas. So although that is a difficulty thing about hydrogen, it's also one of the most beneficial things, because that means that it can actually get inside of our cells. And this is an important thing, and you all know this, but in order for something to actually benefit us at this cellular level, we have to do a couple things. First, we have to take it. We have to put it inside of our body. Then it has to make it through the digestive system, not to be destroyed by the stomach acids or different or enzymes or things like that, which hydrogen gas, of course, is not going to be neutralized by pH or stomach acid, because it has nothing to do with pH. It's hydrogen gas, molecular hydrogen, again, completely separate from the H+ ion with pH. So easily make it through the stomach. Then it has to be able to make it into the blood and the systemic circulation, and then it has to actually go into the cell. And the cell has a cell membrane around it. In order to get to the cell membrane, the things that dictate the cellular bioavailability is, number one, its size. The smaller things are able to get inside of the cell easier than larger things, of course, right? Well, hydrogen is the smallest molecule there is. So it has that beat, number one, hands down. Another thing that dictates the cellular bioavailability is the charge. Charged particles are not able to get inside of the cell as easy as non-charged particles. And so you have something like an ion, like potassium or sodium or calcium. Those are ions. They are ionic, and they have a charge to it. And they cannot get into the cell very easily. They have to go through what's called an ion channel. They have to go through a specific protein channel, an ion channel, to get inside of the cell. They can't go through the cell membrane. If it's a neutral molecule, then it has the possibility, if it's small enough, to actually just diffuse right through the cell membrane immediately without having to be weighed by the body to figure out, okay, should this go in? It just can go right in there without waiting. Another thing that dictates the bioavailability is it's a little more complex, but similar to the charge, but it's polarity. So polar things like water is neutral, but remember, it looks like Mickey Mouse, and that makes it so it has that shape like that because water is a polar molecule. So even water, as small as it is, as simple as it is, and even though it's neutral, water itself has a very difficult time getting inside of the cell. It has to go through a specific protein channel called the aquaporin. And we'll probably need to talk about the aquaporin a little bit more also. But see, water can't go inside the cell membrane, through the cell membrane very easily. It has to go through a protein channel. That's actually why it was even suggested way back when that there has to be a specific protein channels for water, because it was well known that water doesn't permeate the cell membrane, and that water could get from the outside to the inside of the cell and back way faster than you could calculate based upon normal Brownian diffusion through the cell membrane and different things. So it was known that it has to be a channel. But later, when Peter discovered the actual crystallography structure of the aquaporin and proved, yes, this is the channel that water uses to go through, that's how it all came to be. But that reemphasizes the fact that even if it's a polar small molecule, it still can't
I hope you hear me now, because we seem to have lost Tyler, and we're going to make sure we get him back. So please stay tuned. You may have to refresh your link. Let's see how we do this. In case you, I think Sherry is now trying to coordinate with Tyler. That's good. So stay tuned for a moment. This is the right moment to play some nice music. Don't know how to do that though, but I'm sure we'll get Tyler back. Sherry, let me know if you want me to do something else, or if you want us to start the broadcast again. I think we're getting Tyler back. Is that what we're doing? Tyler, are you there?
me?
I hear you now, yes.
Okay, yeah, it looks like...
So we lost you, I will say, some 2 minutes ago, so you may want to back up a little.
Okay, sure. But I'll just summarize the basic parts of all of that. Was that the difficulties of hydrogen, and that it's so small and has all these difficulties in terms of trying to contain hydrogen. That's why it can dissipate out of the plastic bottle so easily, is also one of the things that allows it to have such great therapeutic benefits, because it can actually get not only into the body through the digestive system, but through the cell membrane, and then deep into the subcellular compartments like the mitochondria, the nucleus, and the different organelles where that's where we really need it. And that's the problem with your conventional antioxidants, is a lot of those are they're either charged or they're too large, they're not able to get inside of the cell. And so when you look at the clinical studies on the use of antioxidants, they're really showing they're really not that effective. The conventional ones, you take the pill every day, for example. Anyways, that's some basics of the hydrogen. So now maybe just to talk about some of the history a little bit more with the alkaline ionized water and how this industry developed. Really, it started back in the 1930s or so. We could even go back further into Russia and different things that are going on, but we're just going to start with the 1930s in Japan, where they started using this alkaline ionized water. Really, it was just electrolyzed water. It was both the alkaline and the acidic just put together, and they used it for agriculture use. And then it was suggested, hey, I wonder if we could also use this for human consumption, if that would be beneficial for us. And so they decided they would move forward to try to do that, and they approached the Japanese government, and they're like, you could do that, but in order to do that, we would need to you need to get approval, because in Japan the regulations and restrictions of with the government are actually quite strict. And so you have to get approval by the government in order to use something like this for medical approval. Similar like with the FDA, like dental floss, for example, is also a medical device. It's like a class 1 medical device or something. So it's a similar idea. So what they did is they in the 1964, they finally got the approval by the Japanese government to produce, manufacture, and sell these units as for human consumption, and they were classified as a medical device. It wasn't about curing or treating or preventing disease or that kind of stuff. It was part of the Japanese regulations. And the same thing in Korea, for example. In order to basically manufacture and sell these machines, you pretty much need to get that medical device approval from the government, because there are countries that are much more strict than here in the U.S., for example, with the FDA, or other countries like in Europe. So moving on with that, when they first introduced these to the market, well, people started drinking the water, and they started getting benefits. And more people started getting benefits, and more people are noticing differences in their cholesterol levels and their diabetes and their health and their blood pressure. And now the scientists were like, "What? This is kind of strange." And it wasn't really accepted by the scientists at all. In fact, there were a lot of problems going on in Japan at the time, because there was so much press release going on about this alkaline ionized water. A lot of this I learned when I went to Japan. I was there for some time where I did some research at Nagoya University, where I researched hydrogen gas as a therapeutic molecule on the molecular mechanisms of hydrogen, how it works at the cellular level. And I learned some of this history. I was able to meet with some of the pioneers in the industry that were, that did the stuff back in the 1960s and 70s, for example, when it really first started coming out. So it was a very interesting story, but basically a lot of the medical and scientists, professionals at the time, were very much bewildered by this whole concept of alkaline ionized water, why people were reporting so many benefits, because it did not make any sense that alkaline water could exert these benefits. Because in reality, even if you subscribe to the concept that we need to alkalize our body and eat alkalized foods and taking alkalizing things, even if we believe that, so we're not even going to talk about that right now. We're just going to say, even if you believe that, the fact is, it cannot be done by alkaline water, because alkaline water is not considered a buffer. And that's why just a small drop of, say, soda or lemon juice or something else immediately neutralizes the pH. And in fact, if we consider a comparison, this is just simple math or stoichiometry. If you take one teaspoon of baking soda, just one little teaspoon of baking soda, think to yourself, how much acid can that neutralize, okay, compared to, or how many glasses or liters, how many liters of alkaline water would be required to neutralize the same amount of acid as 1 teaspoon of baking soda can? And the answer is 1 teaspoon of baking soda can neutralize the same amount of acid as 10,000 liters of alkaline water at a pH of 10. So just consider the fact that it is just impossible to get these alkaline benefits from drinking alkaline water alone. That's why it was simply not accepted by the medical community, because it did not make any sense. But there was still something about this alkaline water that made people realize that there's more to the story than this, because people were still getting benefits. And that brings us to some other direct examples of how some of the researchers got involved in this. Dr. Maminoda from Kyushu University, for example, well, her friends came to her and they're like, "Hey, me or my loved one or friends were drinking alkaline ionized water, and these people had Parkinson's disease, and they were getting a lot better." And they're like, "Dr. Noda, can you explain how is this possible? How does this work?" And she's just like, "I don't know. I don't even think it's possible." But she was interested or intrigued enough. She decided to do her laboratory decided to do a study, and they did a study on using alkaline ionized water on Parkinson's disease, and it did work. And then she's like, "Okay, so now we need to do a bigger study and see what's really going on." And she separated every property of the water that she could, by removing the hydrogen gas, by taking the same mineral composition, the same pH, everything, tested all different control groups, and she found in each and every case that she did this experiment, that the only one that offered the therapeutic benefit above control was the one that contained the hydrogen gas in it. And then later she also found the article published in Nature Medicine in 2007 that she's like, holy cow, it's right here. This makes so much sense. When we do electrolysis of water, one of the byproducts of the cathode is hydrogen gas. They've been using this for centuries in the fuel industry, for example, is for mass production of hydrogen gas. That's what we're doing. We're producing hydrogen gas. And a similar thing, Dr. Ki-Ju Lee, he's from Korea. He's also the president of the Korean Water Society. He's very famous. He's also one of our MHF advisors. If you click on advisors on our website, you can see his credentials and things there. We were actually just at a conference earlier in August. The Huffington Post actually covered that, and he was from his organization. But you know, he started a pioneer in this area of alkaline ionized water over 20 years ago. And he started doing the research, and he found that, yeah, this water is anti-diabetic and anti-cancer effects and all these different benefits. But he was still very confused about how could the water have these benefits. And so that's when companies and different people started suggesting ideas of, say, you know, the microclustering or the free electrons or the other enigmatic properties, because they knew there was something more to this water. It wasn't just filtered water. There was something special about it. And so he started doing these studies, and then he came across molecular hydrogen or hydrogen gas very quickly. And so he said, well, I wonder also if it is a hydrogen gas. And he did the exact same studies where he took and he isolated every property that you could. He even took just pure hydrogen gas and then bubbled it or infused it into water and got the concentration to be the same as it was in the other studies that he was doing. And sure enough, the results were unequivocal that it was, in fact, the molecular hydrogen that was responsible for the therapeutic effects. And if the concentration of hydrogen was not high enough, you didn't notice any significant therapeutic effects. So his studies and many other studies have, again, over and over, simply shown that the benefit of this alkaline ionized water was indeed the molecular hydrogen, the hydrogen gas. And when you remove the hydrogen gas, you don't have a negative ORP anymore, and you don't have the therapeutic benefits anymore. And this is a recent finding from the scientists themselves of only a few years ago. So you can imagine if it was only a few years ago that the scientists themselves had discovered that the therapeutic agent in alkaline ionized water was the hydrogen gas, then you can imagine it takes, you know, years later for manufacturers and for companies to recognize the scientific facts and then start talking about, okay, in reality, it is the molecular hydrogen, right? Because the scientists just barely discovered it not too long ago. And so now, if you look around in the industry, for example, in Japan, the big thing being touted by all these who used to be alkaline water companies is it's the hydrogen. It's the hydrogen. Same thing in China. I was in Shenzhen. I was just earlier last month. I spoke at another medical conference, and sure enough, a lot of companies who are realizing the benefit and the therapeutic efficacy is all about the molecular hydrogen. And if we consider your own personal examples, many of you perhaps who have experience with alkaline ionized water, you've already noticed one thing, that if you let the water sit too long, it's no longer therapeutic, and that's because the hydrogen gas dissipates out. And that's why the ORP goes back positive or is not as negative. But the other thing you'll also notice is after you've used your machine for, say, a few weeks or days or months, depending on your source water, for whatever reason, it's like you don't get the benefits anymore, and you're just confused. You're like, well, I don't know. Like, I used to have all these benefits, now I don't really see them anymore. But then you go and you clean your machine, and you get the electrodes nice and clean again, and all of a sudden you feel this boost in energy, and your benefits are all of a sudden reinstated. And the reason why is actually because when over time, the electrodes or the machine can get scale buildup on the electrodes or in the hoses in different places. And even though you still can perform electrolysis, you can still make an alkaline pH, the hydrogen gas does not dissolve in the water. And that's an important thing to remember. There is a difference, okay? There is a difference between producing hydrogen gas and having the hydrogen gas dissolve in the water, okay? The electrolysis machines to make alkaline water, they always produce hydrogen gas. That's why you can light, you can have like a little flame, you can hear the crackling pop, for example. You can, the very definition of making alkaline water with electrolysis is by production of hydrogen gas, because it's about reducing the protons, the H plus ions that we talked about as pH, converting H plus ions to hydrogen gas. So if you remove the H plus ions, you by default have a higher pH. And how do you remove the H plus ions? By producing hydrogen gas. But the second thing is getting the hydrogen gas to actually dissolve in the water. And when you have scale buildup on the machines, then you are going to not have the hydrogen gas be dissolved in the water. And that's why more of the companies who are selling alkaline ionized water, that are talking about the benefits of hydrogen, they're also re-emphasizing, hey, you need to make sure you clean your machines. But more things are being found that with a lot of these machines, if you live in an area with source water where you have very low TDS or very low minerals, you may not actually be getting high enough therapeutic levels of molecular hydrogen in your water. But on the other side, if you live in a place where they have a really high mineral concentration, you will be getting therapeutic levels of hydrogen most likely if your electrodes are clean, but sometimes the pH can be too high. So these are all recent things that are being discovered throughout the industry, and specifically from the academic scientists who are publishing these articles, and now we're learning about them, and I'm hoping to share this information with you. But as you can see, a number of these benefits, a number of these things you have already noticed about having to keep the machine clean in order to maintain the therapeutic benefits, not being able to leave the water out for very long, or else the hydrogen gas leaves, all of these things. But the fact is nobody knew it was the hydrogen gas until just recently. And that's why there's been so much push on, well, what about the structuring of the water, the microclustering of the water, and look at the difference in the proton nuclear magnetic resonance spectroscopy and things. And although those are neat things, they're not as scientifically as valid as we once hoped that they were. I was extremely interested in some of the structuring of the water, and I still am, and so I've done a lot of research on this area, including some spectroscopic analysis of my own and different things. But when it comes to like the NMR, and you have the different resonance, the different bandwidth of the resonance, it turns out that doesn't indicate water cluster size, but rather any deviation from neutral pH. So if you just add sodium hydroxide to increase the pH, or if you add hydrochloric acid to lower the pH, you have a deviation from a neutral pH of 7, you're going to see the exact same similar bandwidths. So it's more of a change in pH. Or if you add different ions to the water, you can see changes in the bandwidth. So it's not about water cluster size. The other thing people say, well, what about making the tea, for example? A lot of people have seen that if you take alkaline water and you take the green tea, you can just keep on making these cups of tea over and over again. And that's actually pretty neat that you can do that. But it's actually a theme that's even used in elementary schools when they're teaching about science experiments and other places for showing pH indicators. So a lot of us know the pH indicators you buy for your swimming pool and different things. This is just a natural pH indicator. And so if you have a neutral pH, then it's going to turn, the color is mostly clear. You don't really see anything. If you increase the pH, it turns more green. That's a pH indicator. So you can actually take your tea bag, for example, and if you put it in your normal water and you let it soak for a while, it's pretty much clear. Now take and add, say, some sodium hydroxide or just anything to increase the pH, all of a sudden it turns nice and green, dark green for you. And I did this actually with the spectrophotometer probably four years ago or so, where I took and I just wanted to quantify how much tea was actually being made from the water or not, and there was no statistical difference. In fact, the higher the pH, just the more green the tea looked, just because it was a pH indicator. And a similar thing is also noted from where people say, well, yeah, but you can drink this water and you can just keep on drinking and drinking and you don't get that bloating sensation. So what does that mean? Well, that's actually also pretty simple to answer. In fact, what that means is that it's been well known that acidic beverages are emptied from the stomach into the intestines at a slower rate than higher pH or alkaline beverages, because the gastric emptying, or moving the contents of the stomach into the intestines, is partly a function of pH. And as that pH gets neutralized by, say, the bicarbonate and the pancreatic juice, then it causes a release of more of the gastric contents to enter into the intestines. So if you drink alkaline water and it's kind of on your nerves or things sense this higher pH and things, and that kind of sends a signal to go ahead and empty the contents into the intestines. So that's one aspect, is just because it's an alkaline pH. The other thing is actually from the hydrogen gas itself, where the molecular...
But is there, if I may interrupt,
Sure.
Tyler, is that then that avoidance, if you like, of the bloating feeling of drinking so much fluid? Is that a good thing or a bad thing? I mean, is it healthy?
Well, I would say it's a good thing. You know, for example, when it comes to sports athletes, one of the biggest things that is a rate limiting step in hydration recovery is gastric emptying. And so if we can have a faster gastric emptying rate, then we can have a lot of benefits. And that's why, you know, good sport beverages, they are formulated and calculated with the right caloric density content, the right osmotic balance, the right nutrients, all these things to facilitate gastric emptying. So we can have a faster gastric emptying, get it into the intestines, and we can rapidly absorb it.
So there is then advantage of the higher pH, but also you warn against too high a pH.
Yes.
So how far do you go?
Well, from my opinion, based upon my conversations with other researchers in the field and some of the clinical trials they've done back in the day to get these alkaline ionized water you know, devices approved for safety and things, they have noted that if the pH exceeds 10, that there are some people they can have negative effects to it, and the reason for this is simply not known. It doesn't make sense, but people have noticed that they get like a hypokalemia or low blood potassium levels. People start having diarrhea, you know, that are stronger than what they should, for example. Some other strange and anomaly symptoms, and there's a number of potential mechanisms from the even the degradation of the electrodes and different things, but those haven't been studied enough to really scientifically say this is the reason why. But effectively, the recommendation, the governmental law, for example, in Korea and Japan, is that the water should not exceed a pH of 10. Okay. Now, that's an important point, because sometimes some of the machines on the market, they have like a pH button, like pH 8.5 or 9 or 9.5. Just because it says pH 9.5 does not mean it really is a pH of 9.5. All those buttons mean is just it's a difference in power setting or power level. So a pH of 9, pushing the pH 9.5 button is going to deliver a higher voltage per se to the electrodes than pushing the button 8.5. There's no way you could actually you know, regulate what the pH is. It's just how much power is going to the unit, and it's calculated based off if you live in this source water with this specific TDS and this specific flow rate. Then if you push the 9.5 button, you should get a 9.5 pH. But because source water and flow rate varies so much and greatly, we can't just say that. In fact, pushing the 9.5 button, depending on source water, you know, mineral composition and flow rate, you can have a pH that ranges from 8 to over 12. That wide of a range. And one of the ways, if you look at like the pH indicators, if it turns bright purple, that means the pH is 10 or greater, because that pH indicator only goes to a pH of 10. At a pH of 10, it turns quite purple, and then it just gets more and more purple. So you kind of want to have the highest pH you want to drink, if it was using that pH indicator, is really something closer to the bluish to purplish color, and that's about as high as you'd want to go. Anything more than that, then you know, who knows? It could be problematic long-term consumption. You know, I'm not sure, but that's how it's stated in Japan and Korea, for example, and mandated by the government as well. I have suggested this before, and I think this may help alleviate some of the symptoms if people have that, but there could be more to it, especially if it's a degradation of the electrodes or something, where you could simply add some lemon juice to the water to lower the pH a little bit, and you would not remove any of the benefits of the molecular hydrogen, because hydrogen, of course, hydrogen gas is not affected by pH. Now,
so let's go back to the hydrogen itself, because otherwise
Yeah, exactly. And that was the other point with the gastric emptying, is hydrogen gas alone actually been shown to induce gastric ghrelin secretion. And ghrelin is a hormone that is extremely anti-inflammatory and therapeutic, and has a lot of benefits. In fact, a lot of people here who are into health probably are aware of the benefits of fasting, like the intermittent fasting and different things, because it can help with like DNA repair and help with so many different benefits. Well, one of the things that mediates the benefits of fasting is actually that our body starts to produce more of this hormone, ghrelin. And hydrogen also increases this ghrelin level. So hydrogen is very natural in that aspect. Is some of the things that benefit some of the ways that hydrogen benefits us is mediated through ghrelin. And ghrelin also can induce gastric motility and can help with the gastric emptying as well. So that's why even if you take water that has an alkaline pH, if it's not the alkaline ionized water with hydrogen gas in it, it still may not be emptied into the intestines as quickly as water with an alkaline pH with the molecular hydrogen in it. And so I think that answers most of the questions. If there are other questions regarding, what about this thing for microclustering or this or that, there really are on the website. I go through a number of different evidences and what people have used and thought about the structure of water. And it is very fascinating. I know a lot of work is going on, especially at the cellular level. When we talk about water, forming a structure at the interface of biomembranes and through proteins. That's very well known and very well accepted, and is very, very interesting result. And for those who don't know, just real quick, if you took a sponge, for example, and you put it in water, and then you could just take and you could squeeze the sponge and all the water would drip out, right? But you look at, say, our muscle, 90% water, right, or something. Well, how come you can't take a piece of meat, a piece of beef, and just squeeze the water out like a sponge? That's because water is not free water just floating around. It's structured. It's all intertwined in a specific way, and that's how it is in our bodies as well. And there may be some interesting things with how molecular hydrogen is doing something in that area of the water surrounding the cell membranes and different things as well that could add to its therapeutic benefits. But again, it's mediated through molecular hydrogen and not through some change in the water structure itself initially. At least that's where the current scientific consensus and research is at.
All right. Thank you, Tyler. I'm just wondering, are we at a good point to invite people to come up with their questions, or where are you in that sense?
Yeah, no, now's a great time. I mean, I could go on for 6 more hours. We have a lot more to talk about, but we have
also more sessions. But maybe if this is a good moment, then I would encourage all of you, viewers, participants, to come up with your questions and email them to courses@theoptimist.com, and from there they will be routed to me. So please do so. Meanwhile, I was going to ask you, Tyler. You made it very clear that there is a very important difference between the molecular hydrogen gas and whatever it is that's alkaline water. And now you spoke, of course, about these machines that produce alkaline water, and on the sort of as a byproduct, there is hydrogen gas being dissolved, at least when it's done proper and the machine is new and the electrodes are clean and all that. But we also have, and I was going to ask you about that, when I walk, the shelves of the aisles of the supermarket these days, I see on the shelves all these water bottles that say, hey, alkaline water. Now, What is to that? I mean, is there any hydrogen gas in that water?
Yeah, and really there isn't, because like we talked about, hydrogen is the smallest molecule. It's easily just going to escape right out. And so that's really probably what drove the whole alkaline bottled water movement, is the fact that when people drink alkaline ionized water, if there's hydrogen in there, they get benefits, and they talk to their friends and neighbors, and just grows. And so all these commercial companies come in, oh, I'm going to make alkaline water and I'm going to sell it in the stores. But not knowing that the benefit was not alkaline water, the benefit was hydrogen, which you're only going to get through doing the electrolysis process, right? Yeah. So
there's stuff. I mean, it's really something you don't need to buy then, really, unless you want to say the as you said, it's the alkalinity of water does help the entry of the water into the stomach and feels easier to drink. I mean, that part is there, right?
Yeah, I mean, how significant that is, that's become subjective to how much people like it. Some people just like the taste of alkaline water better. But statistically wise, for those who have not been exposed to alkaline water for a long time, statistically wise, the research actually shows that our thirst is better quenched from acidic beverages than from alkaline beverages. So things that are slightly acidic will actually quench our thirst better. And so that has two benefits. One, maybe we don't want to feel thirsty because it's annoying. We're always feeling thirsty and we have to go to the bathroom all the time. We're like, you know. But on the other hand, most people are chronically dehydrated. They're not drinking enough water. And so drinking alkaline water makes them feel more thirsty. And so they're going to go and actually drink more water, and they get those benefits that way.
Okay. So another question you refer to, you know, the people who may have, even in our audience today, have those ionizer machines that produce the alkaline water with the dissolved hydrogen gas in it. That they are experiencing certain results, and then when, you know, the machine needs to get cleaned, these results disappear. Can you maybe give some anecdotal examples of these, you know, of these, what that is that people experience while drinking the hydrogen gas? I mean, you talk to people all the time.
Yeah. Yeah, well, some of them are quite impressive and hard to believe, but I hear some things so often and so frequently all over the world, all over, you know, because I travel globally to speak at a number of these conferences and things. But some of the most dramatic things that I have heard are in terms of anything to do with like pain relief and inflammation. People who have, you know, say rheumatoid arthritis. And actually, I'd like to use the example of rheumatoid arthritis because there is a double-blind placebo-controlled clinical trial where there was actually a crossover design as well, very good study, that showed that hydrogen was very effective in helping with rheumatoid arthritis. And in fact, some of the patients who had early-stage rheumatoid arthritis, the hydrogen water helped them so much that they did not even register as having disease markers high enough to be considered to have the disease anymore. In other words, they were cured, if you will, by drinking hydrogen water.
Yeah, well, that's pretty convincing. So we're getting questions here, going in a direction that we could expect from here. Susan and Rosemary basically asking the same question. If you were to advise, and they acknowledge that you're not here to sell any machines or anything, what machine would you advise people to buy? But would you, maybe that's my additional question, would you at all advise someone to buy an ionizer machine when you want to experience the benefits of hydrogen itself?
It's a difficult question because it is somewhat subjective, and, you know, maybe somebody really likes the alkaline taste, they just like the alkaline feel, and maybe they still believe to some extent that the alkaline properties. I'm just saying this, there's no scientific evidence for it, and in fact it's pretty much been refuted that there is any. Now, in terms of the machines, there's lots of machines out there that can give the benefits of molecular hydrogen. So I would simply say this. I would say you should find a machine or a company, or well, really the machine, that gives you good amounts of molecular hydrogen regardless of source water. So you should not have to be in a position where you can only use, you know, this specific TDS water, or else you're going to have way too high pH, you're going to have way too low, or all these different things, just to make it easy on yourself. And you just want to make sure that you can, you know, get the benefits. But there are a lot of people who have alkaline ionized water machines who are very happy with them and get the benefits of hydrogen, and they just have to make sure they do the routine cleaning that they need to do, and that's absolutely fine. But now that the scientists have discovered it's the hydrogen, there are more machines coming out throughout the world that are focused specifically and exclusively on hydrogen, because the other machines, they are manufactured to make alkaline water.
Yeah, that's different, of course. So, but maybe it would be helpful. I don't think. I mean, I'm sure you don't want to suggest one brand only, but maybe could we, you know, with your help, come up with maybe, you know, 5 or so that we can refer to, that you at least know that you have some good experiences with. Maybe that is something we can offer the audience. It's maybe not necessarily now, but in the next session or so. Would that be something?
Yeah, maybe we can. I have to think, because there's not a whole lot that are coming forth right now. But I would suggest you just start searching. You can find hydrogen water machines and different things like that.
But even from personal experience, I know it's quite.
I do have personal experience with it, but again, I feel like I'm still coming from the nonprofit
I understand. So maybe we can also help there. So I'm saying to the audience, we'll look into this and get back to you with the next session with some ideas. But before we even go there, it is not the only way for anyone to experience the benefits of hydrogen, molecular hydrogen, because there are other ways, like
there's like even inhalation. I have an inhalation machine. There's
but
a
tell us
hydrogen
about that
producing
then.
tablets.
So how do you inhale that? I mean, can you do that at home, or is that you need to go to a facility, an institution, hospital, whatever?
Well, you can do it at home. It's just not quite here quite yet in America. But yeah, throughout Asia, they're selling inhalation devices, and some of the medical clinics in China, they have inhalation devices. I've been one in Japan and one in China. You go in, you just inhale the hydrogen gas, drink hydrogen water. There's other hydrogen producing tablets that you can just add to water. All of these different products are coming out. And now there's even some companies here in America that are manufacturing and producing bottled hydrogen water in specific aluminum containers with a liner and different things, or aluminum bottles or pouches, and that you can get the benefits on the hydrogen as well.
Yeah, so we would encourage you, to research that yourself. But indeed, as Tyler just said, there are tablets you can dissolve in water. You need to use that in special bottles to make sure the hydrogen gas doesn't escape right away. But that's all there. So, and that's these are cheap solutions.
Well,
They're much cheaper than buying a machine and giving you the same benefits.
Well, and I will make one recommendation because I think it's important. But when you're doing the research, you can always test and measure the concentration of hydrogen. If you can get some of the it's called a redox titration reagent called H2 Blue. If you just Google H2 Blue, for example, you can find the website by Randy Sharp, manufactures and sells it. He also does a lot. But anyways, I'm recommending that's only because that's the only viable method that is easy to use, that is available right now, that you can easily measure hydrogen. You cannot use an ORP to dictate the presence or the concentration of hydrogen. It cannot be done.
Okay, here is a question from Siobhan Rafferty. How is it we do not get enough hydrogen for our health when the gas is so plentiful and all around us?
So with hydrogen gas, we're just talking about hydrogen gas that is flammable, right? We're not talking about hydrogen that is bounded to water, because again, you can't light water on fire, or the hydrogen that is in glucose. These six hydrogens in a glucose molecule. That's totally different about hydrogen gas. And actually, this hydrogen gas is very rare. In fact, the concentration in the atmosphere that we are breathing, is very low. Oxygen is about 21%. Nitrogen is about 70%. Hydrogen gas is about 0.0000055%. So it's very, very low and below the therapeutic level.
So we need more. That's a clear answer. So do we have more of your questions? I'm asking the audience. And maybe, Tyler, meanwhile, you can also give us a little bit of a preview of what you're going to do in the next 2 weeks, because then people can look forward to joining those sessions as well. But again, please send us your questions if you have more at courses@theoptimist.com. But what's on the schedule for you next week?
Yeah, so next week, what I plan to do is there's a couple things I didn't get to finish talking about today, and I'm going to finish some of those and clear up some more of the misconceptions and different things, so we can all be educated and start on the right page. And then effectively, I want to talk about one of the most neat romantic stories, if you will, about hydrogen itself. From the beginning of the time, back in the universe and on, and bring a lot of really neat connections of how involved we have been with hydrogen without even knowing it. And then we're going to be a little more specific on where things are at with hydrogen, how it works, and how we can benefit from it.
And will you be, and that's probably then maybe the final session, you will be more specifically addressing some of the research related to some of the diseases you mentioned,
Yes.
Rheumatoid arthritis today, but there are so many more, right? And I'm sure that our audience is interested in getting an overview of where it can be beneficial.
Yes, exactly. Then I'll give the final day. I'll give a presentation on the impact and significance of hydrogen on many different diseases, and also just some industry insights, if you will, from the research and the industry in terms of where we're heading. Where is hydrogen heading? Where are we going to see it?
Yes, because we're talking about something that we may expect. I mean, even you know, as I started out saying when we began this session, this is something that is very well known in other parts of the world, and specifically in East Asia, where the story really began. And there, people are benefiting from something already for decades, really, and it's only now, largely also due to the work that you're doing, Tyler. It's coming here, and all these companies are finding their way to the US market. But it is something we probably should be sure of, that in a few years to come, that a lot of people will talk about this and a lot of people will use it. And here's the beauty for you. You are among the first, getting familiar with this beautiful opportunity for your health and what else is there. So that is the promise for the sessions to come. And I'm just checking in with Sherry here. Sherry, do you have more questions for Tyler, or maybe you don't? And then I think we're getting, if you agree with me, Tyler, we're getting to the point where we're going to say bye for this session, and we'll see each other again. That is 11:30 Pacific time, 2:30 Eastern next Tuesday. Is that's where we are?
Fantastic. Yeah. So in the meantime, I'd recommend, if you haven't already, go check out the website, molecularhydrogenfoundation.org. Click on, what is molecular hydrogen? You get an overview of it right there. Just, do some reading and be ready for next week. So thank you for your time.
So thank you. And once again, thank you, Sherry, for guiding us here. And to all of you, have a very good rest of your day and a beautiful week, and more hydrogen next week. Thank you.